Hi friends, welcome back to our RxJS tutorial series. In the previous video, we learned what RxJS is and why it is useful. We also looked at a real-world example where multiple API calls produce unexpected results, and we saw how RxJS helped solve that problem in a simple and efficient way. If you haven't watched that video yet, I recommend watching it first and then coming back to this one. In today's video, we will learn one of the most important concepts in RxJS, observable. Before we dive into observable, let's first understand the four main building blocks of RxJS. These are often called the Big Four of RxJS: observable, observer, subscription, and subject. Let's quickly understand how these four concepts work together. Think of them as parts of a pipeline. Observable is the source that produces data. Observer is the receiver that listens to and reacts to that data. Subscription is the connection between the observable and the observer. It starts the flow of data and can also stop it when needed. Subject is a special type that can act as both a source and a receiver at the same time. We will discuss subjects in a separate video. To better understand the first three concepts, let's use a simple analogy. Once you understand this example, the rest will become much easier. Imagine a YouTube channel. A YouTube channel keeps uploading videos. It doesn't care how many people are watching. It simply continues creating and publishing content. Now imagine that you subscribe to that channel. As soon as you subscribe, you start receiving notifications when a new video is uploaded. If you later unsubscribe, the notifications stop coming to you. However, the channel continues uploading videos. This is exactly how RxJS works. The YouTube channel is the observable because it produces data. You, the viewer, are the observer because you receive and react to the data. The act of subscribing is the subscription because it creates the connection between the source and the receiver. Each video notification you receive is like a value emitted by the observable. I hope this analogy makes the concept easier to understand. And by the way, if you haven't subscribed to this channel yet, please consider subscribing. Thank you. Now let's focus on observables. In the simplest terms, an observable is a stream of data that emits value over time. Or you can think of it as a source that produces data over time. An observable can emit a single value, emit multiple values, emit no values at all. The values may arrive immediately or they may be emitted gradually over time. A great example is mouse clicks. Imagine we are building an application that needs to capture the coordinates where a user clicks on the screen. Mouse clicks happen continuously over time. Each click produces new data. This continuous flow of data is an example of an observable. Other common examples include keyboard input, API responses, timer events, WebSocket messages, and so on. These events do not occur all at once. They happen over a period of time. RxJS represents such data streams using observables. At this point, you might be wondering, how is an observable different from a promise? After all, we already use promises in JavaScript. Why do we need observables? Let's understand the difference. A promise typically returns one value in the future. For example, when you make an API call using a promise, you usually receive a single response, either success or error. An observable, however, can emit multiple values over time. This makes observables much more powerful when working with user events, real-time updates, timers, live data streams, WebSocket communication, and many more. Another important difference is how they execute. Promises start running immediately after they are created. Observables behave differently. And that's exactly what we are going to learn next. There are several other differences between promises and observables as well. If you would like a deeper comparison, please check out my earlier video where I explained these differences using multiple practical examples. Now let's move on to the coding part. You can use RxJS in Angular, React, Vue, also even in plain JavaScript applications. In this demonstration, I will use Angular, but the concepts are exactly the same regardless of the framework. I have already created an Angular application. Let's see how to create an observable. There are multiple ways to create observables. In this video, we will use the manual approach. This is the most basic and fundamental way to create an observable because it gives us complete control over what data is emitted and when it is emitted. Let's begin. To create an observable, I will use the observable constructor. First, we need to import observable from RxJS. Next, I will create a variable to store the observable. By convention, observable variable names often end with a $sign. This helps developers quickly identify that the variable contains an observable. Now, if we hover over the observable constructor, we can see that it accepts an optional function. This function is executed when someone subscribes to the observable. Let's add a function and place a console log statement inside it. I'll also print the observables variable itself. Now let's run the application and see what happens. Notice that only the observable variable is printed. The console log inside the observable is not executed. Why it is like that? Because creating an observable does not automatically execute it. The observable has been created, but nobody has subscribed to it yet. The code inside the observable only runs when a subscription is created. This is why we say observables are lazy. Simply creating an observable does not start its execution. It waits until someone subscribes to it. Now let's subscribe to the observable. As soon as we subscribe, the code inside the observable executes. Great. We have successfully created and executed our first observable. Now let's see how to emit data from it. To emit data, we use the next method. Let's emit a value. The emitted value can be anything. For this example, I will emit a string. Since we know the observable emits strings, we can replace the generic type with string. Now let's run the application. Notice that we still don't see the emitted value. Why? Because although the observable is emitting data, we are not doing anything with that data yet. To handle emitted values, we need an observer. Let's create an observer object. Inside it, we will add a next callback function. This callback receives the emitted value and prints it to the console. For now, I'll use any to keep things simple because TypeScript expects additional callback definitions as well. Now let's pass this observer to the subscribe method. Let's run the application again. Now we can see the emitted value being received and printed. Instead of passing a complete observer object, we can also use a shortcut. We can directly pass a function to the subscribe method. Like this. This approach works exactly the same way. Now let's see how observables are used with Angular HTTP requests. I already have a backend server running on port 3000 that returns a list of countries. Let me show you. Next, I will use Angular's HTTP client to call that API endpoint. Notice that this request does not directly return the country data. Instead, it returns an observable. This means we cannot simply store the result in a variable and use it immediately. First, we need to subscribe to the observable. Once we subscribe, we receive the response data, store it in a variable if needed, and then use it in our application. That's how Angular HTTP calls work with RxJS observables. Now let's talk about the observable lifecycle. Every observable communicates with its observer using only 3 types of notifications: next, error, and complete. Let's understand each one. The next notification represents the normal flow of data. Whenever an observable emits a value, it sends a next notification. The observer receives that value and can react to it. Let's see this in code. First, I will create a new observable that emits numbers. This observable will emit one number every second. To do that, I will use the setInterval function and emit a value every 1 second. Let's run the application. As you can see, a new number is being printed every second. However, this will continue forever. What if you want to stop after a certain number of values? For example, Let's say we only want to emit 5 values. In that case, we can use the complete notification. The complete notification tells the observer that no more data will be emitted and the stream has finished successfully. To achieve this, I will add a condition. When the counter reaches 6, it means 5 values have already been emitted. Instead of emitting another value, I'll send a complete notification. Now let's run it again. You can see that only 5 values are emitted. Perfect. Now let's see how to handle the complete notification on the observer side. Instead of using the shorthand subscription syntax, let's switch back to the object notation. Inside the observer object, we can add a complete callback. This callback will run when the observable completes. Let's display a simple message inside it. Now when we run the application, we can see that after receiving the last value, the completion message is displayed. This confirms that the observable has finished successfully. Now let's move to the third notification, error. Instead of sending a complete notification, let's send an error notification. Think of a real-world example. Suppose you are making an HTTP request and the network connection fails. In such cases, the observable would emit an error. Let's run the code again. After the fifth value is emitted, an error occurs and the stream ends. To handle this on the observer side, we can add an error callback. Inside this callback, we can display an error message or perform any error handling logic. We can even pass additional information such as an error object and display its details. This gives us full control over how errors are handled. Now let's try something interesting. What happens if we attempt to emit another value after an error notification? Let's test it. Notice that the value is never received. The same rule applies after a complete notification as well. Once an observable has either completed successfully or terminated with an error, it cannot emit any more values. The stream is permanently closed. So far, we have seen two ways an observable can end. Either it completes successfully or it ends with an error. But there is a third possibility. The subscriber itself can decide to stop listening. This is called unsubscribing. For example, suppose I only want to receive values for 10 seconds. After that, I want to stop listening. Let's see how we can do that. First, I will store the subscription object in a variable. Then I will use setTimeout to execute some code after 10 seconds. Inside it, I will check whether the subscription is active. If it is, I will call unsubscribe. Now let's run the application. You can see that values are received only for 10 seconds. After that, the subscription stops. That's exactly what unsubscribe does. This is one reason why in Angular applications, we often unsubscribe from observables inside the ng_on_destroy lifecycle hook. Doing so helps prevent unwanted subscriptions from remaining active after a component is destroyed. Now let me show you something interesting. I will add a console log inside the observable. Let's run the application again and wait for 10 seconds. Notice what happens. Although we unsubscribed, the set interval inside the observable is still running. The subscription has ended, but the observable is still performing work in the background. This is a classic example of a memory leak. Resources are still being used even though nobody is listening anymore. How do we fix this? If we inspect the observable constructor, we can see that it allows us to return a cleanup function. This is known as Teardown logic. Let's use it. At the end of the observable implementation, I will return a function. Now when we run the application and unsubscribe, this function gets executed automatically. Inside this cleanup function, we can perform any necessary cleanup tasks. In our case, we simply clear the interval using clear interval. Now let's run it again. This time, after 10 seconds, the subscription ends, the interval is cleared, no further values are emitted, everything stops correctly. This helps prevent unnecessary processing and memory leaks. In Angular applications, understanding when and how to unsubscribe is extremely important. We will discuss memory leaks and best practices in more detail in future videos. Before ending this video, there are two more important concepts we need to understand. The first one is observables can be either synchronous or asynchronous. Many developers assume that observables are always asynchronous. That is not true. Whether an observable is synchronous or asynchronous depends entirely on how it is created. Let me show you. First, I will comment out the previous example so it doesn't interfere. Now I will create a new observable that emits a few values and then completes. Next, I will subscribe to it and implement both the next and complete callbacks. I will also add console logs before subscribing, at the beginning of the observable, at the end of the observable, and after subscribing. Let's run the application. Notice the order of execution. As soon as subscribe is called, the observable starts executing, all values are emitted immediately, the observable completes, control returns to the next statement after subscribe. Everything happens in a single execution flow. This is a synchronous observable. Now let's modify the observable and emit the values using setTimeout. Run the application again. Notice the difference. The subscription starts immediately, but the values arrive later. JavaScript continues executing the remaining code while waiting for the timer. Eventually, the values are emitted asynchronously. This is an asynchronous observable. So remember, an observable is not automatically asynchronous. Its behavior depends on the implementation. One final concept before we finish this video. By default, observables are unicast. What does that mean? It means every subscriber gets its own independent execution of the observable. In simple terms, if two subscribers subscribe to the same observable, the observable code runs separately for each subscriber. Let's see this in action. I will create a new observable that generates a random number. Then I will create two subscribers and subscribe both of them to the same observable. Each subscriber will print the received value. Now let's run the application. Notice two important things. First observation is the observable executes twice. Once for the first subscriber and once for the second subscriber. This proves that each subscriber gets its own execution. Second observation is both subscribers receive different random numbers. This shows that the executions are completely independent of each other. That is exactly what Unicast means. Each subscription gets its own separate instance of the observable execution. I hope this concept is clear now. That's all for today's video. In the next video, we will explore the different ways of creating observables and understand the differences between them. If you found this video helpful, please hit the like button and share it with your friends. And if you are new to this channel, don't forget to subscribe and support the channel. Thank you for watching. See you in the next video. Bye.